Agarwal. I'll be your maths expert in askIITians. In this session, I'll discuss some mathematical concepts and their applications. So, without further ado, let's dive in. So, student, I'll be taking up the topic today, Incenter, Incircle, and its application to solve a number. These topics are basically from geometry. Geometry plays a vital role in your school examination as well as in your Olympics. If you see your school examination, it consists of 25% to 35% of the questions from geometry. And similarly, if you talk about the Olympiads, it consists of basically 20 to 40% of it. Yes, if I talk about the Olympiads like IMO, IOM, NTSC, pre-RMO, etc. Let's dive in. What is angle bisector? Here you see AOB is an angle, and if you see AOD such that OD divides angle AOB in two equal parts. If I say that angle AOB is 30 degree and if OD divides AOB such that this angle is 15 and this angle is 15, then we say that OD is an angle bisector, is said to be angle bisector. So, angle bisected in a triangle. In a triangle, we have three angles. That's angle A, angle B, and angle C. Now, we are going to draw the angle bisector of each angle. Angle bisector of angle B is OB ray, such that angle ABE is equals to angle CBE. Similarly, AD is the angle bisector of angle A such that angle BAD and angle CAD are equal. Likewise, we see CF is the angle bisector of angle C such that BCF and ACF divides the angle into two parts. Therefore, angle CF is the angle bisector. Here we see that angle bisector BE and AD and CF meet at a point. This point is known as basically incenter of a triangle. This point is known as basically incenter of a triangle, and it is denoted by a symbol I. Now, there is one thing very important, that incenter of a triangle always lies inside a triangle. Here we see that triangle ABC is a right angle triangle. Okay, so we see that incenter lies inside a triangle. Now, if I move this point over here, now we see that the triangle ABC is an acute angle triangle and still the incenter lies inside the triangle. Now, if I just move this side over here and we see that ABC is again an obtuse angle triangle and still the incenter lies inside the triangle. Now, I'm just for a reference, you can just see I'm just rotating a circle in any manner, in any way, in any direction. I can see that incenter always lies inside the triangle. Okay, so this is the reference we get, that incenter always lies inside the triangle, whatever the triangle may be. Okay, relationship between vertex angle and the corresponding angle at the incenter. So here we see that triangle ABC is a triangle, BI and CI are the angle bisector of angle B as well as angle C, and they meet at a point I. Now, we are going to find the relationship between the vertex angle and the corresponding angle at the incenter. So, basically, we say that this is an angle at incenter and this is the vertex angle. Now we are going to find the relation. It's very simple. Now let us consider that angle ABC be angle B. So I take this angle as B by 2 and this angle as B by 2. Similarly, if I take this angle as C by 2 and I take this angle as C by 2. Yeah, this is possible because BI and CI are the angle bisector of the triangle. Okay, so basically in triangle, if we talk about triangle BIC, we can use the property angle sum property. That's angle B by 2 plus angle I, or I can write angle BIC plus angle C by 2 is equals to what? 180 degree. Reason being angle sum property. Angle sum property of triangle. Okay, so from here I see that angle BIC is equals to what? 180 degree minus half of angle B plus angle C. As we know that triangle ABC is here. So we know in triangle ABC, angle A plus angle B plus angle C is equals to 180 degree. Okay, so we need a relation in a vertex angle, so I can write angle A as 180 minus angle B plus of angle C. So I substitute this value over here, substitute, this is equation number 1, substitute this value in point. Okay, so we see that angle BIC is equals to what? 180 minus of half of 180 minus of angle B. We just need a little bit of simplification. So simplification will be angle BIC is equals to what? 180 minus 90 minus plus of half of angle A. So we see that angle BIC is equals to what? 90 plus half of angle A. Similarly, if you see this is a triangle in front of you, yeah. If I make an incenter, let us suppose this is a triangle A, B and C. If I have drawn angle bisector of A and angle bisector of B and they meet at a point I, then this angle, basically angle AIB will be equals to what? 90 plus half of angle C. Similarly, if you draw the angle from A and C, if I take the triangle A, B and C, so if I draw an angle bisector from A and angle bisector of C, which meets at I, then we see angle AIC is equals to what? 90 plus half of angle B. So this is the important result which we have right now, and you should remember this is a very important result which has been taught in the school curriculum, and this can be used in various Olympiads directly. There we don't need to do the proof part, and this can be used directly. So what is an incircle? Incircle is very simple. What we do is that now we have seen that BI, AI and CI are the angle bisectors of angle BAC. Simple. Now they meet at a point I, and this point is known as basically the incenter. This we have already discussed. Now, if I draw a perpendicular from the point I to the corresponding sides, let us suppose I draw a perpendicular from I to B, let it be point P, yeah. Then this I'm dropping a perpendicular, this is Q, and this I'm dropping a perpendicular, this is R, yeah. Now, taking I as a center, if you see geometrically that these two perpendicular drawings from the incenters are equal. So I can just tell you with an example, like if you see that triangle RBI is congruent to triangle PBI angle side. If you see this very carefully, that angle angle, this angle is equals to this angle side. Yeah, this is the side BI, and angle side. So we can see that by CPCT, RI is equals to what? BI by CPCT. Similarly, if you take a triangle IQC and IPC, you can see that it is again congruent by angle side, angle side. This is CI is the side, and angle side. So from the correspondent by CPCT, we see that IP is equals to what? IQ by CPCT. So we see that Ri is equals to Pi is equals to IQ. Taking I as a center and the perpendicular distance, taking as the perpendicular distance as a radius, we can construct a circle. Okay, we have seen that if we draw a perpendicular from a incenter to the sides and taking this perpendicular distance as a radius, we can draw a circle. This is a circle form. This circle is basically known as incircle. Yes, and the radius generated over here, this radius is known as basically inradius. Yes, and the sides of the triangle act as tangent to the circle. Yeah. Sides act as tangent to circle. For more knowledge and for more details, you can just join askIITians. Will be helping you here. Thank you so much.